All right, seems like a good quorum to get started. Hello, everybody. Thank you for joining us for today's remote sensing webinar. This is my first time with you. My name is Anton Brevde. I'm a partner of Prime Movers Lab. If you're not familiar with Prime Movers Lab, we're a venture capital fund. We invest in breakthrough scientific inventions that have the ability to impact billions of lives. We invest across a wide variety of industries: energy, infrastructure, manufacturing, transportation, human augmentation, agriculture. Today, we'll be talking about space and more specifically remote sensing. Space is an area that we're extremely passionate about, have been very active in. There's a lot of exciting inflection points that I think a lot of us are familiar with, so I won't belabor them, but most notably the massive decrease in launch costs, which have really, depending on the metaphor you want to use, turned a dirt road into a highway, now making it much easier to get into LEO and GEO and into orbit. And so now it's for us investors a question of, and founders, what are the things that should be going up there? And today we're going to be talking about one of the large existing markets. Sometimes we talk about manufacturing in space or space computing or asteroid mining, things that are more kind of long-term markets, but remote sensing or Earth observation, imaging of the Earth is something that is already an existing large market, one that we're quite excited about here at the fund. We've made a recent investment in Alpha Insights, which is a SAR-based company. Scott is here joining us, so we'll be excited to dive into that company, and also excited to have Vince and Adam here as well. So before kicking it over and getting started, just some quick housekeeping. It will be an hour-long webinar, so we'll end at the end of the hour at the dot. We would love to have questions from the audience, so feel free to put that in chat or into the Q&A functionality of Zoom, and we'll answer those as we go through the webinar. And I think with that, I'd love to pass it over to my partner for today, Christie Iacomini.
Thanks, Anton. I'm really excited to be here. I'm the VP of Engineering for Prime Movers Lab, and my background is space. So this topic is of course really interesting for me. I don't have any background specifically in remote sensing, so I'm super excited to be having our panelists here today and like to give them an opportunity to introduce themselves. So we could start with Scott Larson, CEO at Alpha Insights.
Yeah, thanks so much. My background in space, this is my third space startup. My second in Earth observation. My first one was a company called EarthCast, which was in the optical part of the Earth observation industry. I was the CEO there for 5 years, stepped down 5 years to the day to do another satellite company, which was mobile communications. We're building out a satellite-based IoT network. We sold that about 1.5 years ago to a company called EchoStar, and then I had the opportunity to be one of the founders of Alpha, Space Alpha, which is in the synthetic aperture radar market, the SAR market.
Great, thank you. So obviously it's going to be some great insight for our conversation today. Next, Vince Deno, I'd like to introduce you as you were at Millennium Space Systems.
Yeah, thank you for that, Christie. So you could say I picked space over being a fighter pilot. I was under Air Force scholarship for ROTC. I dreamt of flying F-16s. By the time it came around to picking a career field, I actually opted for acquisitions. So I was exposed to new space. It was called responsive space, early 2000. I was at LA Air Force Base, and toward the latter half of that, I was exposed to industrial opportunities. So commercial SpaceX had just opened down the street, and it was a lot of opportunities. So I joined Millennium about that time and helped build the company from single-digit people and millions to triple digits. We were end-to-end space system provider, and we really focused on national security space. So I supported a wide range of mission areas, including electro-optical and in many capacities. So thank you for the opportunity.
Yeah, this is great. Thank you. And then last but not least, we've got Adam Maher, our CEO and founder at Ursa Space Systems. We're excited to have you as well. So tell us a bit about yourself.
Yeah, thanks for having me. So yeah, I guess my adventures in space kind of started all the way back in college, but started with doing small satellites there, but went to this other company later that done large geocommunication satellites. So basically, you think about your direct TV type satellites to home. And then as part of that, actually, part of while I was there, this transition into this new space the new changes in the space economy started to happen and started interacting with companies like Millennium Space. And they're looking at how do you take and how do you architect new architectures, was originally looking at, communications, how do you bring broadband, internet communications to the world, and then actually transition, started getting into Earth observation. So worked really early on with a number of companies, the skyboxes, the planets, and then, had this realization, everyone said, hey, these optical satellites are great. This idea of being able to, this idea of being able to like take a picture of the world every day was really fascinating. But if you had optical satellites, you got a picture of clouds every day. and so anyway, so got into this idea of, hey, if I take the ideas of communication satellites, these ideas of, Earth observation satellites that were, we combine them together, you can get radar, which sees through clouds, sees at night. And so then that's where, how I started my journey into founded a company that specialized, we were originally going to build radar satellites, and now we've really transitioned into how do we take the data from those satellites, use it with other data sets to really understand what do commercial markets around the world, want to understand about the information that's produced by these assets.
Awesome. Thank you, Adam. So before we jump into some more detailed questions, maybe we can kind of set the table for the audience who might not be familiar with the different modalities of optical imaging versus SAR versus RF or near IR. So maybe we can kind of look at it in two ways. One, just a bit of a historical overview of kind of the traditional ways that we've observed the Earth and who's done that, what do those satellites look like? And then a second part of kind of looking at what is different now, what are the new space companies pursuing? Scott, maybe you can give us a bit of historical context on the industry.
Yeah, sure. I mean, the Earth observation market industry sector has been, just kind of looking at Earth from above, goes back 40, 50 years. Started purely government, black and white cameras that somehow worked and would, it would just kind of drop film down that would be collected. And that was back in the 60s, and it was only government. And then over the last, from a commercial standpoint, in the last 25 years, I suppose, it's kind of broadened both in terms of the types of cameras, the types of imagery, which went from optical, kind of just a black and white image, and then added color, so you could get color images. And then, of course, it's flowed through to different bands of imagery. And so it's not just red, green, and blue. It might have 5 or 6 different bands in there, including things that can detect crop health and water levels and amounts of pollution, if you will, all the way up to hyperspectral, which might have a couple hundred bands. And that, again, can determine if the paint on a tank was made in India or China, as an example. And so there's huge amounts of information that you can get from sensors in space. And that's purely on the optical side, if you will. And then over the last number of years, it's kind of morphed into radar. As Adam mentioned, you can see through clouds, you can see at night, you can kind of see underground, you can see through trees. And so the market started historically government. It began to expand in terms of what type of data and information you could get just as the technology advanced. And then from there, it's moved into the commercial market, which is where everybody on the panel here is obviously trying to focus, because that's where we see the real upside, being able to take Earth observation data, somehow democratize it, first to commercial and then perhaps down to individuals. And so it's generally a small market in the single-digit billions, Earth observation, growing at 15% per year-ish on a CAGR basis, historically government, and then moving rapidly into the commercial market. And so if you kind of use that to frame what Earth observation is, it's smallish industry, limited number of suppliers, growing demand, and everybody trying to figure out how to access the data better.
Yeah, makes sense. Adam, yeah, could you, go ahead, Adam.
I was gonna say, but that categorization of it being a small industry is really very specifically looking at it very narrowly through the straw of just data that is provided by a very specific type of satellites. Versus if you look at it from a larger, so if you look at Earth observation from a larger perspective of the things that have come off of it and what it enables in your daily lives, it's actually a much larger market. So the current value And so the thing is actually, it's really interesting actually that the intermediate market here is actually larger than the entire aerospace industry. Yeah, but it's just dominated by a couple select companies like the Googles, ESRI, but that market there, if we look at, how much, of your daily life is, actually interactive with geospatial data, it doesn't have to just be satellites. If you start looking at all the other forms, that's a market that is in the hundreds of billions a year, approaching trillions a year. Like there's some interesting facts of like, geospatial data sets like these actually impact over 75% of global GDP, are used to create better efficiencies on that. And so it's I just want to make that point that like, if we look at it from a very narrow perspective of, a data set, it may seem small, but if you look at it like its overall impact, it's actually quite a bit larger. You can think about, GPS on your phone and optical imagery. How many of you have used Google Earth, in the last 24 hours? That is all data that comes from these systems. And so and then when you start putting that together, it's really interesting how much impact that can have to the market.
I would be interested in any other examples beyond that. Like as we look into the next 5 or 10 years, like what is the next? Oh, I used it to get me to, the grocery store in the next town. What is the next examples of?
Jump in with something I think that Anton said really resonated with the context is the fundamental shift in launch market. Compared to 20 years ago, we're at 2 orders of magnitude difference in cost basis for launch. So access to space. And if you kind of think about that in a housing market, it's like in LA paying $1,000 per square foot. Now you can buy a house for $10 a square foot. But the problem is you have to buy a 200,000 square foot home and use it effectively. So the market has shifted. So there's large opportunities, but figuring out how to take advantage of that makes sense. But the key to space, for people that are less familiar with this market, space is all about scale. It comes in the form of persistence or access or coverage, but it's very rare to find a useful business case in space that is very, very small market size. To Adam's point, the multimodality, the layering of geospatial data is compounding, and it becomes exponentially more valuable as you increase your scope and your scale. So, and then that shift in the launch market is what I think really creates the commercialization and the opportunities for new space companies. And frankly, I think that's why you're seeing kind of the explosion of interest in the public and private markets, enabled by that fundamental shift in the cost and access to space.
And Vince, on that cost point, and maybe if could you speak to a little bit of kind of how has the hardware changed, right? So these satellites used to cost hundreds of millions, and now depending on the application might cost low single millions. Kind of what's changed there for startups?
I think to Scott's relation in historical context, when it was the US and other nation states had very unique set of requirements, whether it's Title 10 for intelligence or Title 50 kind of war and defense, national security. They didn't have a cost requirement, they had a mission. So enter today, in commercial markets, the change in the unit economics, the access to space, when you can launch your own satellite for single-digit millions versus hundreds of millions, enables a new, I would say, breed and different type of solution space. In business, there's no extra credit for difficulty. So if you can approach an existing market with a simpler, faster solution, that's more cost effective, then you have a huge opportunity.
And I think to answer your question about where some of the big markets are coming from, what are some of the big applications that are coming in the future is, I think it's an interesting world that we're starting to come into, because I can even think of examples of how many folks have opened New York Times recently, even Wall Street Journal, and seeing satellite imagery or seeing references to to other companies, other intelligence companies, and they're starting. And so what we're starting to see is I think we're starting to see one is this there's this broad kind of kind of the news media is starting to adopt it, and so they're starting to adopt this and starting to say, whoa, this is really interesting. For us, for my company, we've already been selling subscriptions to numerous different companies who use this a lot like a news feed to say what's going on in the world. And so this is, I think, one, this is starting to bring a new layer of news. But I think two, I think the other one that's going to really drive this over the edge is really thinking about the environment, really thinking about environmental impacts and how those are starting to have personal effects on folks. And I'm sorry, that's one of the things we're starting to see a lot of is like how does somebody look and see how is that impacting them? And actually these data sets are actually quite useful for doing that.
Maybe thinking about, so we talked about historically governments being the main drivers in this market and now all of these commercial applications. Scott, it might be interesting to get your perspective as an active founder of a remote sensing company. Kind of how do you see the go-to-market for these companies in kind of navigating government customers, non-government customers, kind of where are your priorities right now? How do you see that changing in the future?
Yeah, I mean, the way that Earth observation companies started 20 years ago was through government funding. They were all kind of large defense contractors that got government contracts. In the last 10 years, 10, 12-ish years, you've seen a bunch of startups down in the valley, a couple of internationals, of course, who come at it purely from a venture capital standpoint, which is let's just make something that kind of works, get it up there, it's good enough, it's cheap enough, and then look to scale from there. What we've done is kind of halfway in between that, which is trying to come out with government quality type data and then look to expand that, and look to kind of scale into the commercial market using first a government customer or government entity as a contract, as an anchor customer, and then scale from there. When you're working with governments, they're all difficult. That's just the reality, is it doesn't matter what government, where they are, they all have their own mandates, budgets, issues that they're trying to deal with. They're just difficult customers. But of course, as Adam mentioned, they have budgets, they have missions, they're not so concerned about costs. And that would be perhaps the SpaceX model, which they went after NASA as an anchor customer, and then have expanded down into some of the other small startups like us as launch customers. And I think we're trying to do the same thing. It's tricky. Space is fundamentally hard. You have to prove out tech and then raise financing on that, or you have to prove out revenue visibility and raise financing on that, or somehow manage your way through both of those. It's by no means easy, and it's a CapEx intensive business. And so if you're building satellites, building stuff that goes into space, it's fundamentally expensive. It's not easy.
Maybe going back to you, Adam, as someone who is selling a lot of this SAR data to commercial customers, you talked a little bit, or we've all talked about some of the use cases for SAR specifically, but maybe you could provide some more examples, like kind of what is this information being used for today?
Yeah, so yeah, there's I think actually part of our problem as a company is we have too many use cases, and it's actually hard to focus to like really be, because there are so many things it can be used for. So just I can give you a number of different use cases depending on the type of customer you're looking for. And so we have so we can look at one area. I think there's a whole area of, I would say, customers who are just really looking to understand kind of more on a statistical or financial basis what is going on in the world. And so these are folks who are looking at, so for example, like one of the things we do, one of the products we sell is we track the entire oil supply chain all the way from when it leaves the ground to when it gets delivered to refineries. And so and even within that, you can look at it could be oil storage, it could be the ships moving it, it could be the status of pipelines and refineries. so those are things that are really interesting. But then we look at other folks who are actually starting to really react to situations. And so that, that's a whole new that's a little bit different category of folks. So these are folks who are usually these are users who are out there in the field who say, hey, I need to go find, there was a damage. So for example, there was a damage somewhere could be from a hurricane, could be from a flood. And they're looking to understand what was that damage, what was, where do they go respond? Well, to other folks who are looking to, they're looking to plan and understand, okay, where do I most, where is it the best place for me to go place my resources to be ready to respond to a situation that's developing in this part of the world or another part of the world. And so, so with those cases, we've had there's a lot of great success there on, so part of it is understanding at a global scale, global statistics, what is really happening in the world. And the other one is understanding at a local level. You may hear a rumor, can you go actually look at that? You hear a rumor or you hear, like there's a lot of this mistrust in what you hear from open sources, could be a social media or something like that. Even in the news, there's a lot of, is this, what is the, kind of full extent of this? And so we can go look at those really quickly, so we can go look at those and assess, okay, this is, this is the status of that factory being built. And I think it all stems from like just the basics. We're all used to this. We're all used to, I open up my cell phone and you open up your cell phone and you don't even get finished typing food, and it's already told you, here's all the restaurants you're interested in. So I mean, in the commercial world, it's the same way. You're out there, you're getting asked to evaluate something that maybe is in South America, and there really isn't an an automatic infrastructure that's already like, monitoring that system all the time. And so that's where we end up a lot of these great use cases.
Those are a lot of great use cases. It impresses me how we're extending something like SAR to enable all of that, right? I'd love to ask Scott, obviously investors are excited to invest in SAR. What are you most excited about with this opportunity?
When you look at the SAR market, we view it as a little bit of where the optical market was maybe 20 years ago, which is the SAR market. It's historically been difficult. SAR data is difficult. It takes a lot of processing. SAR satellites, it's been difficult technology. And so the optical market has been ahead of the SAR market by about 15 years. And as Adam mentioned, and everyone kind of knows, the amount of Earth observation from an optical standpoint data that's in our everyday lives, it's all around us. And so being able to take a little bit of SAR data and see how that's going to play out, what kind of impact it can have in basically how we can democratize it and take advantage of the SAR market opening up, is I think where we see the opportunity. There's really only been 3 or 4 providers into the SAR market over the last number of years. It's the Canadians, it's the Italians, and then it's the Germans. And now in the last 4 or 5 years, there's a few startups, of course, that have started up, funding, satellites going up, data coming out. It's all excellent data, high resolution data. And I think we feel the opportunity is to be able to participate in that, continue to service some of the government customers, and then look to expand the market as it opens up with easier to access data from a SAR standpoint that is always on. You can always image SAR, day, night, optical, maybe you're getting 25%, but SAR, of course, it doesn't matter. And so that's kind of where we see the opportunity. There's basically layers of opportunities here, both from a technology standpoint, from a demand standpoint, and then just being able to participate in the supply side.
One of the things that we haven't talked, we talked about SAR, but what about the ability to use that data quickly and in real time? That seems like something that is an enabler that maybe we didn't have 10 years ago.
One of the things that we are our technology. I don't want to plug what we're doing too much, but we're coming up with what's called SAR XL, which is XNL band. And without getting too technical here, it's satellites that aren't particularly small from a satellite standpoint. They're kind of mid-market, if you will. They have two different bands. L band gives you wide area coverage, and so we can see kind of 400 or 500 kilometers wide at a time, and that gives you the ability to survey, kind of just see whatever you see. And then built into our payload on the spacecraft side, we have onboard processing. And so we have some machine learning built in there, which if the L band sees something that's interesting, let's say a ship, it's flying over the Indian Ocean, it sees a ship. It automatically directs the L band radar to take a high resolution snapshot of that ship in kind of half-meter resolution, which is considered high resolution. And then further on top of that, so first you're surveying, then you're identifying, then you're classifying, that's a ship, and then you can say, is that a military ship? Is it an ocean tanker? So you get more information, and then ultimately you get down into the analytics side, which is it's a ship, it's commercial, it's an ocean tanker, and it's 50% full based on the wake. We can analyze the wake and we can tell which direction and so forth. And so now you're getting down into detailed information, all done within seconds. And so this is real-time information because it's small, just real-time information, which is unique in the SAR sector.
And I see we had a question from Scott about examples of types of data things SAR can see that other modalities can't see or can't see nearly as well. I will pull up quick an image of a SAR image. The thing is, it looks like just a black and white optical image, at least to me. And I'm going to plug Adam's blog, which is great if you want to learn about kind of how SAR works. So I'm just going to pull up a picture here. So he's got this helpful little diagram. The image on the right is a SAR image, and this is clearly illustrating that if it's cloudy, an optical satellite is going to see clouds. Whereas a SAR image can see through that and get you, below 1 meter resolution imaging of a city. And so shout out there to the Ursa Space blog. But Adam, Scott, or Vince, anything else you'd want to add to Scott's question about kind of what the unique aspects that you can see?
I think I would just say with SAR. Oh, go ahead.
Yeah. So as at night for sure, through trees, to a certain extent underground, so through the canopy, there's an unlimited amount of data that you can capture with SAR. But Adam, go ahead, please. Yeah, expand on that.
Yeah, I was going to say, I think the basic way to think about radar and these other pieces is really instead of, so we've always been very used to optical because it's what we as humans are easy to look at. But when we talk about radar, when we think about radar, or even, another new field that's coming up, RF mapping, or what we mentioned before, hyperspectral, what we're looking at here is we're saying, okay, these are all measured. I would say, think about these more as measurements. So when we take for example, when we take a radar image and like you go to our website, you can see like, hey, we got this cool 3D thing of Paris. But like what ends up happening though, is we end up taking lots of information. We combine that to make an image. In reality, the real power is actually in the, it's kind of, we think, connecting to the computer processing, because we can really start measuring things. We can start measuring very fine displacements. Like I think a lot of people are really always surprised when I say, when we go do an analysis where we say, oh yeah, we can see this building or this dam is shifting, kind of measure that down to the centimeter level, millimeter, centimeter level, like how much a particular object is starting to shift. Or when we start looking at things and we say, with radar, not only do you see, let's say there's a vehicle, but you actually can measure from radar that speed of the vehicle. And so it's really interesting when you start looking at that, just the and the bit depth, because even though like with radar, we show these black and white images, that per pixel bit depth is actually something on the order of like 256 bits per pixel versus 16 bits per pixel in an optical image. And so that depth of information is so much deeper, which you can do. Even behind me, I have Dubai, and you can see it's a little bit fuzzy over here, but then it's clearer in here, and that's the differences in wave pattern that's going on. There's a little bit, that difference in that shading is actually the difference in wave heights and wave direction that's going on in this particular image behind me. So.
Thank you. Something that I think is interesting to think about, this might be a little contentious. I'll start with you, Vince, here as a neutral third party, is there's a few different business models. There's Scott's business model, which is developing your own hardware, launching it into space, and then having control of that data. Or you can choose to avoid that first part, which is quite challenging, and be a data aggregator as maybe a potential investor or a founder. Or just enthusiasts, like kind of how do you view that trade-off between those business models?
Well, geez, I think you could frame it in many ways, but I think from a founder's perspective and an investor's perspective, I think it kind of the same thing. You need to understand the value chain. We've already touched on this, is a very capital intensive business. It's very difficult technically. But also the other challenges I think are not so much in the value creation, it's capturing the value with so few sales channels. Like, you really need to understand your customer, the intrinsic value of what you're delivering and where you fit in the overall value chain. Otherwise, like, you could create the most amazing tech in the world and it will do nothing financially. So I think that's really key. And once you've honed in on that, then you have the decision of, do you want to raise a tremendous amount of money from day one and sell the vision? Or are you going to go with the incremental approach, build, test, fly, and capture the value? So I personally feel that the macroeconomics of space and the current kind of investment environment lends itself to go incremental and go very, very fast. That way you can really just focus on what the value drivers are and demonstrating the value. It's traditionally, space has been a very top-down driven, like waterfall, multi-billion-dollar acquisitions that take decades. And I think we know what those systems look like. They definitely have a market purpose and customer set, but the more flexibility of greater access, lower unit economics, I think are far more interesting for new space entrepreneurs and investors.
Yeah, and I guess the thing that makes me think of is, and there's obviously pros and cons to both approach, and maybe we don't need to go through them all right here, but something that's interesting, we diligence a lot of remote sensing companies, and sometimes I kind of think of the concept of a minimum viable constellation. Right, if you are going to be a hardware provider, and Vince, you spoke at the beginning, the importance of having high revisit, you need to reach a certain scale. And kind of when we run through these pitches, it's kind of figuring out, like, how are you going to cross that chasm? So kind of be interesting to hear from the panelists, kind of Scott, I'm sure it's something that you've spent plenty of time thinking about, certainly something we've spoken a lot about. It doesn't have to be specific to Alpha strategy, but like in general, like, how do you think a hardware-based remote sensing company kind of crosses that chasm to get to that minimum viable constellation?
Yeah, I think as Vince mentioned, it's knowing who the customer is, and can you come up with something that actually gets close to what they're looking for. There's a number of space companies that have launched satellites in Earth observation and then tried to work backwards, which is, we have this data, now can we go generate a customer after that? And in some cases they've managed, and in other cases they've kind of struggled because the data doesn't have the richness that Adam was mentioning, or they've missed out parts of the chain in terms of the getting the data down, the processing, or the delivery of it. It's a complex sector for sure. So I think if whether you decide to focus on something that's, we're going to build a larger satellite, we're going to collect data, and then kind of go through in a bit of a scaled approach, staged approach, or you're going to kind of go as fast as you can. There's merits to both of them for sure, and you can argue both sides, but you really have to know who the customer is, and are you meeting some of their needs, because space is so popular, and it's just popular these days, and it's easy to get stuff in space, much easier than it was 20 years ago. Clearly, I think there's a bit of a trend to let's just put stuff up in space and then look to find customers afterwards. Sometimes that works, it doesn't.
Let me just touch on that for a second, because I think that's really key to what Adam was also meant. The richness in the data is misleading. These systems are so highly technical, and they're also somewhat special purpose. It's very, very difficult to build a Swiss Army knife of a satellite. And anybody that walks into a business case saying, I'm going to build tech because it's cool and I can afford it now, that doesn't have that business case and that end value really captured clearly in the business plan is really ripe for a company getting beat around over the course of its development and its lifetime. I do, like to Scott's point, I feel it's extraordinarily important you understand that end game and work it backward to understand what is that minimum viable product. And once you have that, you still need partner or partners that have deep conviction and deep pockets, like that they know what those next steps are and can keep you on that trajectory. This is not a game where you can be software agile. You can be agile, but you're not going to fundamentally pivot into a new market segment.
Yeah, but I think kind of going back to, and it's cool because kind of if we look at that piece of it and kind of going back to the original question about, what's the right business model to go into here, the reality is actually we need folks we actually need companies who are in both of those different business models, because really what's happening in space right now is kind of what happened in, I would say, early 90s in the internet era, where the community of companies that create the overall system are starting to come together. There's folks, there's individuals who are building hardware, and they need to become, kind of like back then, you had to become the best there was at a particular type of, of hardware. And then there's other companies who are building the software that allows these pieces of hardware to interconnect with each other. Then there's other, individuals and companies who are building the applications that someone at the end would use, and then there's a series of users starting to come up. And so, my kind of view on this, it's an ecosystem. It's an ecosystem that's coming together. So, we can have, Scott mentioned, we can have the satellite that detects a ship, but that detection is interesting, but nowhere near as interesting as if that detection, the next company takes that and fuses that piece of data with other sets of information, says, oh, hey, you know what, that ship that we just saw, this is that's ship so-and-so that's carrying this cargo and has this history of activity. Therefore, that's an interesting ship to go think about. And so, and so that's not something you would necessarily do. That's not necessarily something, that's not necessarily something you do from a hardware standpoint, but that's, kind of, those are some of the, when you start thinking about the application, bringing context, bringing importance to the data, such that it actually, has some sort of meaning or impact on a user.
Just maybe to jump in, one thing that kind of jumped out at me as you were saying that is something that makes us so bullish on new space or space, whatever you want to kind of categorize it as. There are network effects that are being developed where kind of not necessarily every specific space company, but a lot of the N+1 space company adds value to the whole ecosystem. And whether it's kind of mesh networks that help all of these remote sensing companies connect and get information down faster, but a lot of these companies that are kind of pursuing different applications end up having ancillary benefits to the entire system as a whole. And so you can kind of see this developing, and it's one of the reasons why we're so kind of long-term optimistic about this market.
Yeah, I think one of the realities of the Earth observation market right now, and this is what Adam mentioned, of course, is that the human element is moving much further down the value chain. And so, if you go back to the standard example of counting cars in a parking lot, in Walmart's parking lot, 20 years ago, they would send university students out to do it. Someone counts the cars, they call up a number, they leave. Yeah, there's 57 cars, they hang up, and then whoever's aggregating that data would do that on a kind of on a macro scale and determine what Walmart's sales are going to be next month. Then they started doing that from space. They take a picture of the Walmart parking lots, and then they would have someone with a magnifying glass counting it by hand. And so you're not counting one parking lot, you might be doing 20 or 30 a day. And then of course, now it's all done by machine learning, and there is really no humans involved in that. And as in all these other examples that we've talked about, all these other use cases of Earth observation, as the human component moves further and further down the value chain, kind of towards the end of the end of it, it just allows us to scale. And you can take the data that you get from Earth observation, the information that you get from Earth observation, and integrate it into virtually every other part of our lives.
I think another interesting dynamic, so just to maybe throw out some jargon here, so LEO, low Earth orbit, versus higher Earth orbit or geosynchronous orbit. So many of the new players in this industry, like Alpha, for example, are going to be producing smaller satellites in LEO, whereas traditionally these were bigger satellites at higher altitudes. Vince, might be interesting to kind of hear your perspective on that trend. Do you think that will reverse at some point? What are the trade-offs? How should we think about that?
Sorry, Anton, can you say that one more time? I caught the other.
Just the trade-offs between lower altitudes, smaller, cheaper satellites, and more of them versus higher altitudes and bigger satellites.
Yeah, I think in a commercial context, right, we'll keep national security space out of it. It's understanding where you're driving value, where you're capturing value, and then finding the simplest, most economic solution. But again, I go back to the physics and the economics that have changed in the last 20 years are really motivating much larger throw mass at a much lower price. And so I think if you look at the opportunity that represents is satellites that wouldn't have been cost effective due to the scale are now cost effective. And by scale, I mean much physically larger, but less complex. That's the trade-off to me, is complexity versus cost. And if you can throw something that's really big and dumb, simple to execute on, that could be a tremendous advantage compared to something that is very exquisite, very technically challenging, and very expensive. So again, LEO is very close. It has a lot of advantages in some sense, but from a physics perspective, I think you can kind of think about space comes down to power aperture. The more power and the bigger of an aperture, whatever the phenomenology is, that's a good trade-off. So that allows you to throw bigger satellites, go big, go far. And that's a new trade space that I think was not economically viable 20 years ago. So, and if you look at that, those solutions are fundamentally different than what I think you're seeing flying in LEO or other specialized orbits today.
And do you think that requires kind of continued progression in the cost curve and launch? And is that assuming kind of Starship works out, or like, what are your assumptions kind of baked into that?
Well, I mean, when you can throw 20 tons into LEO for the same price that you would throw, a couple 100 kilogram satellite into, it just motivates a bunch of different options. I don't want to be too bullish on in-space manufacturing or assembly or servicing, but those become fundamentally new opportunities that did not exist 20 years ago. So, Adam and Scott probably both love power aperture, but the way that they kind of get around the economics of the day are they take advantage of the LEO environment, and they do it for both economic and technical reasons. But I just think that there's more opportunity given the scale of launch as it exists today and how it will continue to exist for the next 20 years.
Scott, what do you think? Are you sticking with Leo or what?
Yeah. I mean, it's physics matters, as Vince mentioned, and for sure the direction of physics is that when you combine physics with launch, is that you can launch big stuff to geo for cheap, and launch isn't zero, but it's trending towards that, at least insignificant. So yeah, if you can build large spacecraft that really stretches physics and get then that makes sense. I don't think we're there quite yet, just because the launch isn't zero and physics is difficult. But yeah, that's the path we're on. For sure, that's the path we're on.
And just maybe unfair question, but like back of the napkin, could you just set a little context for the viewers in terms of like what are the dollars per kilogram now? Like where do you feel like they would need to be approximate, like order of magnitude?
Yeah, so launch costs have come down 4 or 5 times in the last 20 years, maybe even more, I guess. If you want to put something into geo, it's going to be 2,000 to 3,000 kilograms. It just is, in terms of the sensor size. You want to have a large telescope so you can see stuff from geo. It's basically a government type satellite. So if it comes down another 5 times to get to geo, I mean, most of the new launch vehicles, of course, are going to LEO, and some of them just going to LEO. They're just getting up to 500 or 600 kilometers, and so to get to geo, you're up at 30,000 kilometers. There's not a ton of options for that. There's more coming for sure, but it's another few years of launch costs going down to make some of those economic trade-offs work, but it'll happen.
Yeah, maybe just physically speaking, like when you talk about LEO, geo is about 50 times further away than quasi LEO orbit. And for remote sensing, talk about sensitivity, or you're about 300 times less sensitive for the same size power aperture, just from the R² power law. So you have a factor of 300 to overcome by going that distance. And I still maintain we get 100x by the unit economics, but I think it really goes back to, can you make the systems simpler? To make Adam's and Scott's systems work in LEO has been done, but it's not simple. It's very far from that.
I'd like to pivot a little bit away from Earth. We've been talking about what sensors we have and how they can be used for commercial applications as we do Earth observation. I'm curious if anybody has thoughts about how this can be leveraged as we look away from Earth and get into space exploration, maybe mapping of the moon, for example. Anybody have any thoughts on that?
Yeah, I mean, I think it's really interesting thinking about, I was actually just on a panel a couple of weeks ago with a number of, research scientists, and we were talking, a lot of the aspects we were talking about were mapping moons on Saturn, or mapping, and so it's really interesting because the same technology that's used for mapping Earth is the technology that's used for like mapping these other these other parts of the solar system here, for example. So could be radar, optical, all these modes. These very similar sensors. They fly around Mars. There's ones flying around the moons of Saturn. Looking at these, and so it's really interesting when I noticed like there's some other questions here about like non-government applications, not necessarily feasible today, but in the future could have like really incredible or mind-blowing impact on humanity, and they kind of come together. So for example, like it's here on Earth, as we start to map our Earth and map it well, and make this more accessible to individuals, we can really start to understand what is our impact as humans on Earth, and how does when we translate that to other planets, like, or other systems, like how can what we learn from other systems or what we've done on Earth, the things we've changed, how does that impact? Or even, you know, if you think a little bit, let's even go, maybe go more to the sci-fi piece of it. You know, how many people have watched every sci-fi movie where the spaceship like comes into Earth, you know, comes into the planet's orbit, and it says scan planet for, you know, scan planet for life, or scan planet for something that's going on. And, you know, it's kind of crazy thinking that, like, you know, we've just been doing some projects right now where, you know, we're doing that today. We're like, literally, we're coming in and customers are saying, hey, I've got 20,000 facilities. Can you tell me which of the three, you know, there's maybe only 2 or 3 of those facilities that actually have, you know, the activity of interest going on there. And can you, on a, you know, at a daily to weekly basis, tell us which of those facilities to go look at? And like, it's literally what we're, and it's kind of mind blowing to think that, you know, now we can start understanding our climate impact, but we can start, you know, thinking about these other planets, understanding them. It's the same sensors, same technology. And then how do we start thinking about, you know, now we can start looking at these extra, you know, these other extraterrestrial bodies, and, you know, we can start detecting, hey, where is there activity of interest going on, and how do we hone in and look at that when we go. And if you think about the mass problem, we're just talking about launching, that's an even harder mass problem, because now you only got, you know, they're years away, you know, and it takes a bigger launcher. And so you're really being able to pinpoint those locations and optimize is really important. So anyways, I know there's a lot of pieces to that, but that was definitely lots of applications that are interesting to think about.
Yeah, for sure. And you touched on John Ashton's question, where he asks about non-government applications that maybe aren't feasible now, but could have an incredible or mind-blowing impact on humanity. Any other comments or thoughts from you on that, or from anybody on the panel?
Yeah, just on the on your comment about mapping, you know, the moon and planets. One of the things that we've had a couple of inbound calls on is because L-band is typically what you use to detect water, and we have L-band SAR. Can you point it at the moon? Can you point it at other planets? Can you scan other planets and determine if there is water, or if in fact there ever was water there? And so, you know, these are, I'm not 100% sure that the economics add up for that kind of project yet, but certainly it's intriguing. And so, you know, things that have come in out of the blue to us using L-band to detect water sources on the moon, Mars, whatever it is, before humans go there, has landed on our radar, so to speak.
Yeah, I think maybe one interesting one to add there. This is just kind of this is one of those ones that one of those realizations that when you're working with customers and users out in the field, you like would have never thought of. But kind of remember how I was just saying, like, there's all these facilities that, you know, tens of thousands of facilities that we're looking at. One of the really interesting things that we found that happened when we were out in the field and testing this is the thing that the users were most excited about is they were able to get turn-by-turn driving instructions to the locations of these very remote things. And I was reminded that, like, even within the United States, like, you get outside the United States, like, turn-by-turn driving instructions don't exist very much. You know, in a lot of countries, most of the world, that's not available. And so something as simple as that, as we take it, we really, you know, take for granted here in the United States, even rural parts of the United States, that's not available. And so I just remember these users that we had on the field. I mean, man, they were just so excited. They're like, oh my gosh, like, yeah, we saved an entire day trying to make it from location A to location B, and understood the context of where we're going just so much better just by being able to have that, that something that's simple like that. It was just really amazing, you know, working with these individuals and seeing how something as simple as that, how changing, you know, how much that really changed their their view on this technology.
Good reminder that mind blowing is based on your perspective, and turn-by-turn directions would be very mind blowing if that's something you didn't have access to before.
Exactly.
Anything else mind blowing you guys want to throw out there before we get another question? Okay. So Andrew McKee asked a question. not necessarily specific to remote sensing, but satellites in general. I'm imagining I'm going to get some tight lips on this. I've been learning more about the defense world, and people seem very squeamish about talking much. But any comments about how to make satellites more defensible from bad actors who might attempt to destroy them?
I mean, look, Anton, I can lean into this a little bit, not any specificity for any company, but I think we need to be sympathetic and empathetic toward, governments. The context and environment has changed from near peer actor states to nation states, and now literally private and public companies have the same capabilities that were only on the drawing board 50 years ago by the US. So I think there's an existential risk and threat, and at the same time, it's also an opportunity for all governments to kind of reevaluate how they work with commercial and private space. So the short answer is there's a lot of opportunities for policy and law. That's going to be evolving, but it's not very far from how we're kind of navigating cyberspace. Cybersecurity is a tremendous issue for government and private alike. So the analogy starts to break down, but a lot of it is just new tech enables new risk and a lot of policy and law and coordination. So it's just going to take a lot of time. I do think that if you look into the more civil side, the Outer Space Treaty, the Moon Treaty, there are a number of not-for-profits. I won't plug them here, but they're already engaging in a broader community. And how do you approach things like, can you build a base on the moon? What's ethical? What does that look like as a natural resource? And I think the dialogue will have to extend from something that's as meta as the moon, where it's not as far-reaching and not as impactful necessarily, but we're gonna have to bring it back to Earth.
Yeah,
I think go ahead, Scott.
Yeah, so it's an interesting question, because if you take pictures of Earth from space and you disseminate, that comes with a certain level of responsibility. I mean, if you're taking pictures of a war zone in Africa and there's some type of conflict, and you're taking those pictures and you're disseminating them, that information matters, and it matters to people on the ground, and it affects lives. Yes, it's good information. It's a little bit like journalism, so to speak. But if you're taking a picture of tanks at some place in Africa on the ground where there is some kind of conflict, and you're kind of democratizing that and putting that out there through an API or releasing it or whatever it is, someone wants that information. And maybe the UN wants it, maybe some nonprofits want it, or maybe some warlord in the next country over wants that information, and it comes with responsibility. And so from a government standpoint, who wants to implement some type of shutter control, which is you can only take pictures of certain things, yeah, we're sympathetic. We're sympathetic. It opens up all kinds of questions on privacy and access to information and all the rest of it. But it is something that shouldn't really be done without some level of thought and acknowledgement of this is a tricky situation, and there's you're taking pictures. Most of what we see, of course, isn't that life-threatening, isn't going to make a huge world of difference to lives, as an example, but some of it does, and you have to do it with a certain level of diligence and responsibility, because it in fact matters.
Absolutely. Well, I know we hit time here. This was a really fun conversation. Thank you, Vince, Scott, Adam, Christie, and all of our attendees for joining. And we'll see you in 2 weeks for the next webinar.
Thanks, Anton.
Bye.